This is Core Mathematics. This is an additional study that you can study alongside your other A-levels. It is a level 3 qualification, which means it is equivalent to A-levels and an EPQ. To get us started, here is a typical question that you may get in Core Mathematics. How many pizzas are eaten in the UK in 1 year? You'll be given no more information than this, and there'll be a few facts that you know or you can estimate to work out what the answer to the problem is. Have a little think about that. We'll give the answer at the end of this presentation. Here's a bit more information about core maths that comes from the exam board. As you'll see, you'll need a grade 4 in GCSE maths to be able to do the course, and there'll be a lot of problem solving work done, and most things are set in a real world context. The government actually set this qualification up for a few purposes. From their own point of view, they were concerned that the general population are not good enough thinking about money and looking after money and understanding finances generally. So they wanted to make sure there was a good chunk of financial mathematics. Employers were finding that young people going into the workplace didn't have the required numerical skills, so they wanted to have some sort of problem solving side of things. And higher education and universities, they were finding that for non-maths courses, students' numeracy skills just weren't strong enough because they hadn't done any more maths since GCSE. So they wanted to make sure that students were doing a bit more maths, even if it wasn't A-level maths. As we said, the qualification was introduced by the government, and that is a level 3 qualification. So it is in fact equivalent to an AS level. It gets the same UCAS points as an AS level. And UCAS points are the points required to actually get into university. You'll see there that the course is set up so that it's kind of very supportive for those sort of financial courses and sciences, social sciences courses. And as we said, that you'll need a grade 4 to get onto the course. And some students with an actual grade 4 will be successful, although a lot of the grade 4 GCSEs do find it quite difficult. So you are better off if you've got a higher grade than that. It is certainly easier than doing an A-level or an AS in mathematics, that you can be seen from the entry requirements, but it certainly won't be an easy choice. There'll be a lot of new ways of looking at maths, thinking about maths that you'll not be familiar with from GCSE, and that will suit some students more than it suits others. On this slide, there's a couple of interesting things for you to sort of click through. The first one is a video that was done a few years ago by one of the early centres to pilot core maths, and it gives a kind of student's perspective of what they found core maths to be. Then there's a link to the STEM website, which gives a bit more details on core maths, its background and what it hopes to achieve. And as you can see from that quote there, there's an increasing sort of want from universities for these extra courses on top of the A-levels. So EPQ and core maths are now the preferred one instead of actually doing a 4th AS level. And the last little link there is just to give you an idea of what some universities are actually doing with their admissions policy around core maths. You can see from sort of Bath universities that they'll actually reduce one of your grades by 1 level if you get a good mark in core maths. Let's have a look what's actually on the course. The specification link is there if you want to have a look at that. You will notice that it's split up here really into 2 halves. On the left hand side you have what's the compulsory parts of the course, and on the right hand side there's an element of options that you can kind of take. You'll notice that there'll be some topics here that you recognise, so a lot of the data work will be similar to things that you did at GCSE. The estimation work there, and the Fermi estimation, that is similar to that pizza question that we asked you at the start of the presentation. This middle section here on personal finance, that should give you an indication of how much of the course is related to finance and dealing with money, etc. This is a typical piece of work that you may well undertake in core maths. This looks at someone's wages, and you'll see from the top that if you had a gross income of 50,000, then you'll have all these deductions for tax and national insurance and student loans, and at the bottom would work out how much your net salary would be per month. This would be using an Excel spreadsheet, and we do try to use quite a lot of spreadsheet work throughout the course where we can. Specifically looking at the statistics option that you can take, you will see some things here that you will recognise, like correlation, but there'll be some new topics like the normal distribution. Here's a couple of different types of graphs that you will look at in statistics. So on the left hand side here you have a scatter graph, although it's very beautifully presented, and it's just looking at whether eating more chocolate actually makes you cleverer. Now, as you can see from the graph there looks to be a positive correlation between the two, but does that mean that if you do eat more chocolate you will be cleverer? On the right hand side here we look at different types of distributions. So the middle one there is the normal distribution, which we do a lot of work on, and the top and the bottom one indicate an element of skewness, which is another topic you will look into. The second option that we offer at the college is the critical path and risk analysis option. Now here you would recognise topics like probability and Venn diagrams, but there'll be a lot of other new work that you will come across in the course. One of those new topics would be critical path analysis, and here we can see a project that is being undertaken, and the idea here is for us to work out how long that project would be. That project could be something like putting up a new building somewhere, and we would ideally go through, we'll have lots of different jobs that need to be done. How long overall will it take? On what particular day should what particular job being done? And other things around that we would look at would be these charts around it. They're often called Gantt charts, and that's an area that we would look into. If you choose to do core maths, you will need to make a decision at the start of the course which module you would like to do. We offer the two modules, statistics or critical and risk analysis. So which one should you choose? Well, first of all, if you are of the mindset that you just want the easiest one, what is the most interesting, what's the easiest, I just want to get a grade out of this, then we'd probably recommend the critical and risk module. This one we find that more students find the new work here interesting, and you tend to be a bit more successful if your maths is not as strong as other students. You also won't need a new calculator for this particular one. If you're choosing core maths to support other subjects, then we split that down for you to give you an idea of which subjects tend to lend themselves to others. This is fairly flexible around this, so certainly you do not have to be doing those subjects to choose that particular module, or indeed if you're doing those subjects you don't have to do the particular module suggested. If you're doing it just because you'd like to do a bit more maths, then any of the options fine. The module part only takes up 1/3 of the overall course, so largely you'll be doing the same work whichever module you are on. An important point to get across at this stage is that we will not be teaching you psychology, geology, chemistry, etc. Within the core maths lessons. Yes, there may be a little bit of overlap, but it's more the actual mathematical ideas that should help you out. The fact that you're doing more maths should help you in the other subjects, rather than us teaching you how to do those other subject-specific maths topics. It's the problem-solving part of the course that many subjects like. We hopefully will teach you how to think logically through problems and in many unfamiliar situations. If you'd like to have a look at the previous exam papers for the course, then we've put a few here that you can follow the links. So there's paper one, which is the compulsory work that everybody does, and then there's the two options there, the statistics or the critical and risk. Each paper also has a pre-release that comes with it, so if you'd like to have a look what comes on the pre-release, follow those links. Specifically, how will this work actually at the college? Well, we have 4 periods a week, which is usually delivered in 2 double lessons, and a double lesson is 1 hour and 10 minutes. We have no homework, we have no coursework. We find that students can be successful without those sort of extra bits of work. And we also want core maths to be a very light option. It's your A levels that you need to concentrate on. This just needs to be an additional study that you are studying alongside your other subjects. You'll find there's quite a lot of discussion work and lots of activities. If you want to have a look at what the textbook that we use is, there's a link here. Okay, back to the pizza question we asked you at the start of the presentation. How did you get on with it? We would estimate that there will be about 500–600 million pizzas eaten in the UK in 1 year. How did we come up with that figure? Well, what you probably should do is have a think about how many pizzas do you have over a certain time period. So 1 a week, 1 a month, and then are you average? Do you think you have more than average, less than average? So it feels fairly sensible to estimate that the average person will probably have about 1 pizza a month. Now, what is the population of the UK? Well, the population of the UK is about 70 million, but not all of those would be eating pizzas. You wouldn't have babies eating pizzas. Probably very old people wouldn't be eating pizzas. So if you estimate that there's about 50 million, 60 million people who are capable of eating pizzas, times that by 12 for the pizzas eaten within a year, maybe 10 to make life easier. 50 million times 10 will give you 500 million.